So in today's first video on algebra, we're going to have a look through certain expressions, phrases, words, the vocabulary that you're going to need to talk about algebra and formalize it. In order to do this, I have a few notes for you to take down. What I recommend you do is you listen to me explain through the notes, and then once I've finished explaining, pause the video and then write the notes for yourself. So we'll go screen by screen. So in algebra, we have letters. X, Y, A and B are examples of letters that can be used. You may also sometimes see Greek letters like alpha or beta, for example, used. And these letters stand for variables. Now variables is underlined because it's a really important word in the discussion of algebra. And I've given you here a definition of this word in blue. So variables are things that can change depending on the situation. So to show you how this works, we need to start talking about expressions. In the expression 3x plus 2y, x and y are variables. We can substitute any number in for these variables, x and y, to evaluate the expression. So we can change x and y depending on the situation or depending on what we want to investigate. This is an expression because it stands alone with no equal sign. And again, I've given a kind of definition for the underlined word in blue here. So an expression is just something that stands on its own. It's not equal to anything else. Once it is equal to something else, it's called something different, and we'll go through that in a moment. So there are three different kinds of expressions. We have monomials, and I've given you the German in the green colour that German normally is in, here. And these involve one term that stands on its own. And actually, monomials is a word that you won't see very often in English. In English, you're more likely to see the expression term to describe these. And in each of these, I have letters, but I could equally well just add a number. So 8 is a term on its own, for example. And I'll do that so you don't get confused with an equal sign or a subtraction. Then we have binomials, which in contrast to monomials, they include two terms or letters. So you have 2a plus 3b, or 5x squared minus 4y, for example. You might also have 5x squared minus 4x, you could have, or 5x squared minus 4. Then we have polynomials, and these can involve any number of terms. So normally more than two, otherwise it's generally referred to as a monomial or a binomial. But as you can see here, this is an example of a polynomial. Now these expressions here, these phrases, words, they're not so important for you to learn to be able to use them yourself. I'd just like you to be familiar with them so that if they come up, for example, in exam questions, you're not scared by the new language or they seem familiar to you. There's one final term I'd like to define in terms of expressions, and that's the term coefficient. So in the term 2a, this monomial term we have from up here, a is the variable, as we've already learned, and 2 is the coefficient. So the coefficient is any number that comes before a variable that's multiplied with the variable. So please now pause the video and take notes on this first screen, and then we'll go on to the next one. So I assume now you've paused the video. Let's move on. So the next thing I want to talk about is the world of formulae. Formulae is the plural. You have two formulae if you have one formula, and a formula is something that can be used to calculate amounts, and it can normally be applied to certain situations. And we have some examples here of formulae. You might encounter lots of formulae in physics. In fact, I expect you do. Here's an example of one. Force equals mass times acceleration. This means if you have the mass and you have the acceleration of a body or particle, you can calculate the force. Or, of course, you can rearrange this formula to find out the acceleration, if you have force and mass, by dividing both sides by the mass. So this is one that you might have encountered already in physics. If you haven't yet, don't worry. I'm sure there are many examples that you've already seen in physics of letters that stand for certain quantities, and you can then figure out other quantities. In mathematics, we'll sometimes use formulae from physics, but we will more often use formulae from geometry. This is a formula for example, a formula to calculate the area of a parallelogram would be a formula in geometry. And as I mentioned already with F equals ma, formulae can be rearranged to create new ones based on the information that you have. If you pause the video now and take note of this, and then come back to me, then I assume you've now paused the video. I'd like to now just take you through certain shapes in geometry that would be useful formulae for me to know that you have. They're on pages 47 and 48 of your book, but I've put the shapes here for us to talk through together. So this shape here, this is called a square, if I spell it correctly. That one's a square, and you'll notice on page 47 that we have a equals a squared underneath this. Now this tells us if we have a square of side length a, this tells us how to find the area of the square, which is if we were going to paint the square, how much paint would we need? It's that kind of question. It's the area inside the square. And so the English word for this is area. Underneath, it also gives you that you can calculate u about the square, which is 4a. And this is how far, if you were going to walk around the square, how far you would need to go. And in German, it's represented by the letter u. In English, it would be p, which stands for perimeter. So we have a square. This shape here is called a rectangle. The sides don't have to be the same length. Here we have a rhombus, where all of the sides are parallel to each other. So we have two pairs of parallel sides, and all of the sides are of the same length. I'll put that there so you can read it. Similar to a rhombus, we have this shape here, which is a more general rhombus, a parallelogram. And in this shape, it's like a rhombus in that it has two pairs of parallel sides, but the sides don't have to all be the same length. I guess a rectangle is to a square, like a parallelogram is to a rhombus. Then we have this shape here, which is a kite, which has two diagonals, which are at 90 degrees to one another. This shape here is a trapezium. Remember the stress on the E, trapezium. This shape here is an equilateral triangle. A triangle where all of the sides are the same length. A triangle, I think this one looks like it's equilateral as well, but I just wanted to show you a triangle that only has two sides the same length. That's an isosceles triangle. And finally, we have a circle. We also have some three-dimensional shapes on that part, but I think we'll leave those for the moment. We'll be looking at geometry in more detail later on, not in the context of algebra. And so we'll go through these shapes again then, and also then our three-dimensional shapes, and add a couple more in. I just wanted to give you some vocabulary so you can start talking about these shapes in English. And on pages 47 and 48, you have the formulae, how to calculate the area and the perimeter of each of these shapes. And for the three-dimensional ones, you also have formulae for the volume of those shapes. So we've looked now at expressions and formulae. Let's move on to the final area I want to look at, which are equations. Now, an equation is something that's always true. It has two sides to it that are equal. To solve an equation, you need to make sure that the two sides always stay equal. And in order to do this, you need equivalency transformations. And we'll talk about those in more detail at the moment. But what I'd like you to do is I'd like you to think about each equation you have as a kind of balance, as a set of scales, about a pivot here. If, for example, on this side you had 3x plus 5, and that had to be equal, let's say, to, 8, then the equivalency transformations are what make sure your scales are always balanced. So, for example, if you take things away from this side, so you remove things from the scales, you have to remove exactly the same from this side so that it stays balanced about the equal sign. The equal sign is the kind of balance that you have. Similarly, if you put things on your scales, then you have to add exactly the same amount to both sides so that they stay equal. And it's all about keeping things equal. A transformation is not an equivalency transformation if it doesn't keep everything in balance. Now I'll go through the equivalency transformations in the next video. Please now pause this video on this screen so that you can write out these notes, and I look forward to seeing you in the next video where we can briefly go through the different kinds of equivalency transformations.